All right, we're going to continue with our lesson 14, session 3. We're going to, like I said, continue with estimation, but this time instead of fractions, we're going to go back with decimals. And to really get us back on track with that, let's do a quick warm up. All right, so for this one, it asks us to use base 10 blocks. We don't have those available, so we'll just practice them here on the side. So the first one we have is I'll just actually do the work over here. Let's do 3.5 plus 2.4. So again, make sure your decimal points are lined up. And before I do any calculations, I usually bring it straight down. 5 plus 4 is 9. You don't have to carry anything. 3 plus 2 is 5. And that is 5.9. And of course, some of these you could probably do in your head, but if you can't, don't worry about it. Just line them up and do the math. All right, for this next one, we have 1.7 plus 2.7. Now notice that for these, I'm putting the first number on top, the second number on the bottom. Remember, with multiplying and addition, the order will not matter. You could switch them to either position and you get the same answer. Subtraction is different. It's more pretty strict with that. You've got to put it in the right order. But let's do 7 plus 7 is 14. You notice I carried my 1, 2, 3, 4. That gives us an answer of 4.4. And the last one, we have 2.3 plus 0.8 or 8 tenths. And bring down my decimal point. 8 plus 3 is 11. Carry my 1 over to the ones place. 2 plus 1 is 3. And that gives me the answer of 3.1 or 3 and 1 tenths. So 5 and 9 tenths, 4 and 4 tenths, 3 and 1 tenths. Remember the decimal point, we pronounce that as and then it's based on that. Okay, nice quick review for that. Open up your textbooks to page 281, and we'll get started. All right, so Scott's conducting a science experiment. He has 3 and 74 hundredths liters of liquid A and 3 and 65 hundredths liters of liquid B. He pours both liquids into a container, so we're adding them together. How much liquid's in the container? Estimate and solve. So let's split our workspace into 2 parts. Let's have our estimate over here. And then we'll do the actual on the other side here. But we need an estimate first to see what our answer probably should be. And for this one, we have 3 and 74 hundredths liters and 3 and 65 hundredths liters. Let's round up to the nearest whole number. I've got 7 in the tenths place. That's 5 or greater, so that's going to increase that to 4. I've got 6 in the tenths place for this one on the right. It's 5 or greater, so it'll increase that to 4. And 4 plus 4 equals 8. So our answer should be around 8. The actual answer, we can put our numbers here. Again, making sure my decimal points are lined up. 5 plus 4 is 9. 7 plus 6 is 13. Bring down your decimal point. 3 plus 3 is 6 plus 7. 7 and 3/9 liters. So I'm just going to put a big L there for liters. And 8 is fairly close to 7 and 39 hundredths. So that's reasonable. That checks out. And this answer is okay. Go ahead and turn the page. Now, a couple alternatives on how to do it the way we just did it on the previous page. You can picture an estimate of the problem using decimal grids. Here we've got, in these decimal grids, I've got one group of 100, 2, 3, and then I've got 7,400 out of the 100 there. But as you can see, you've got 4 grids, so that's why this estimate can be 4. Same over here for 3 and 65 hundredths. I've got 1 whole, 2, and 3, and I've got over half of these blocks filled in for this hundredths block. So that will also equal 4. So the actual sum, an estimate of the sum is 4 plus 4, as we talked about. The actual sum can be found by finding 3.74 plus 3.65, which we solved previously. Let's look at down below. You can use a number line to help you estimate. And this is how we'd use this one. 3.74 and 3.65 are both between 4 and 3 and 5 tenths. So what they're saying here is you could put these two values on the number line and you can pick which one of these they're closer to. Now, 3.74 is just slightly closer to 3.5 and 3.65 is close. So that's where they come up with an estimate of 3.5 plus 3.5. And if you add those together, that will give you an answer of 7, which again is very close to our actual answer of like 7.3 something, 7.39. So number lines work. Again, you find your benchmark numbers, like you're easy to work with numbers, then you find out which one of your actual numbers are closer to that and figure it out that way. So either technique works. Let's answer some questions. Look at picture it. Why is 4 a good number to use for each addend in an estimated sum? Simple as this, 4 is easy to add. Simple as that. Number 2 is the actual sum of the measure of liquids A and B in picture it less than or greater than the estimated sum. It's less than. And why is that? Because both estimated measures were bigger. So let's put that there. We're bigger. So if you're using bigger numbers for your estimated answer is going to be bigger than your actual. Look at model it, which is the second one with the number line. Why is 3.5 a good number to use for each addend in an estimated sum? Same answer as number 1, 3.5. It's easy to add. Is the actual sum of the measure of liquids less than or greater than the estimated sum? This one's different. The actual answer is greater, and that's because both estimated measures were smaller. They're both smaller. So we used 3.5 for both. The actual measures were 3.74 and 3.65. So your estimate is going to have to be smaller because you're using two smaller numbers than the actual. 5, explain how you can check if a decimal sum or difference is reasonable. The actual and estimate are close. Again, really just common sense with that one. And it makes a lot of sense for that. Okay. Let's do, you can go ahead and cross off 6. We're not going to do that one. So let's skip this and let's get right into the work here for these two examples. Sean has 12.6 meters of garden netting. That's the little, that's like the temporary fence stuff you put around it so animals don't get in and eat your food. He has 12.6 meters of it. He needs 15.85 meters to enclose his garden. So he has that. He needs this much to actually go all the way around. How many more meters of netting does Sean need to buy? So let's split this in two. Let's estimate And let's round 15.85 meters. That looks like that could be 16. This 12.6, we can probably round it up to 13. So if he needs 16 and he has 13, he'll need 3 meters total. And let's find the actual. That would be 15.85. I put my decimal first, so I make sure my second number lines up properly. Again, if you don't, you might shift your numbers to the wrong place values. All right, I'll put a fake 0 there. 5 minus 0 is 5. 8 minus 6 is 2. Bring down your decimal. 5 minus 2 is 3. And 1 minus 1 is 0. He actually needs 3.25 meters. So it'd be good for him to actually buy, probably buy a little bit more than his estimate. But he has a general idea how much he needs. So again, when you start buying things that you'll need for your homes in the future, you're going to have to get like rough estimates of what you need, because stores don't always have the exact length, amount, or weight of things you need. So this is be very, very useful to you as adults. So 3.25 meters, more garden netting. Let's look at 8. Erica wants at least 6 kilograms of apples for a recipe. She picks a 2.56 kilogram bag of red apples, a 1.18 kilogram bag of green apples, and a 2.79 kilogram bag of yellow apples. Does Erica need to pick more apples? Use estimation only to decide. So pay close attention to what they're asking here. And we can do that by taking our values. Here's our red, here's our green, and here's our yellow. So these are the numbers I'm going to come up with for that. Let's do 2.5. I'll pick 2.5 for this. This one, I'll pick 1. It's going to put a decimal. I don't need it. That'll be 1. And then this 2.79. I want a number that's going to add nice and easy with this other 2.5. So I'll do that. All right, so 2.5, that equals 5.0 plus 1, that equals 6. Be 6 kilograms. So she wants at least 6 kilograms of apples for the recipe. That means down here, Erica does not need to pick more apples. She has just enough. So if you make anything with apples, your slices are all going to be these kind of different size shapes and weights. So you won't always get the exact perfect amount. And it doesn't really matter in the end with what you make. And let's do this last one. For this one, Vin is having lunch at a cafe. He has $15 in his pocket and has already ordered a sandwich for $8.57 and a drink for $2.34. Vin also wants to buy a side salad for $5.25. Does he have enough money? Estimate or find an exact answer to solve and show your work. I'm going to estimate because this is something I think you will run into when you're older, maybe if you're going out to eat with friends, and you need to kind of figure out if you have enough to cover your portion of the bill, or before you walk up to the counter at a store to buy, or a restaurant to buy food, you got to make sure you have enough to cover what you ordered. So the sandwich, this is $8.57. I'm gonna go low with with all my estimates here, because I don't want to cut it close. So I'm gonna say $8 for a sandwich. I'm gonna say the drink. That I'm gonna say this is gonna be $2, and that salad is $5. So I've got 8 plus 2 is 10, plus the 5, and that gives me 15. However, um, does he have enough? No, because all my estimate prices were low, and if I use low estimate prices for every single item he wants to eat, and I came to 15, that means if I did actual, it's definitely going over 15. So Vin does not or doesn't have enough money. So he can't have his salad. He's got a sandwich and his drink. That's why you go to a restaurant and you order water. It's free. You don't need to buy it. And you can have your salad and your sandwich. Okay. So that'll do it for this question, of course. That's fine. Let me go over your homework. So my Smart Ink starts to work here at the very end, of course. You're doing H8, estimating sums and differences of decimals using rounding. You're going to round your decimal numbers to the nearest whole number and then find it for that. So it's going to be adding and subtracting for those. And again, just taking what we learned today in the lesson and notes and applying it with IXL, get to your 70% for your bronze medal, and then you'll be all set.